Welcome to today's lesson on solving equations using addition and subtraction. So, quick introduction. So here I have a scale, and you can use a scale or mobiles, but the idea of the scale or mobile is that you want to keep both sides balanced, which is exactly what equations mean. When you have two things equal to each other, they are balanced. So let's look at this equation. Let's say we have some variable m. We don't know how much that weighs, what it is. Well, let's say we add 5 of something to it, and that gives us on the other side, let's say it is 20. So what we need to do is figure out what m is. So I think we could do mental math to figure it out, but let's just look at how we might solve this. So we have m and we're adding 5 to it. Well, why don't we take this 5 off? We'll take the 5 off by subtracting 5. Now, to keep this in balance, we need to also subtract 5 from this side of the scale. So now what do we have? We have m plus a 5 and a minus 5. Well, those cancel, and we're just left with m on the left and 20 minus 5. Well, that turns into 15. So in the end, we have m on the left, 15 on the right, so we could say m is equal to 15. Let's go ahead and look at a slightly different example. So again, let's use m. So we've got some variable m, we're not sure how much it weighs. And then if we took off 5 from that, let's say we would get 30. So in this case, our equation is m minus 5 is equal to 30. Well, we want to figure out what m is, so how do we undo subtracting 5? Well, let's add 5 to the left side, and to keep this in balance, we need to add 5 to the right. And that leads us to the notion that, well, negative 5 and a positive 5 cancel, that m is equal to 35. Right? Now I think you could tell if we put this back in the original equation, again our original equation was m minus 5 equals 30. Indeed, if m is 30, 35 minus 5 is indeed 30. Alright, so that's a quick little introduction. So when we're thinking of equations, think of either a balance or a mobile or a scale or a mobile that we need to keep balanced. All right, so some quick vocabulary. So for our 3-3, solving equations using addition or subtraction, the first term is equivalent equations. So equivalent equations are equations that have the same solution. So equations are equivalent if they have the same solution. And then we have this notion of solving an equation. So to solve an equation, we need to isolate the variable. So we just want 1x or 1y or 1m. So we isolate the variable by using the inverse operation or undoing. So on the previous slide we had m minus 5. So to undo subtracting 5, or if you think that as a negative 5, we add a positive 5, right? And remember to keep things balanced. What you do to the left, you must do to the right. Let's go ahead and take a look at some examples. So we're asked to solve x minus 5 equals negative 1. So I like to draw a little dotted line here to represent my balance. So whatever I do to the left, I have to do to the right. In the end, I just want x is equal to some value. But right now, x, we have a negative 5 here, or subtracting 5. So how do we undo, what is the opposite, the inverse of negative 5? Well, it's a positive 5, or adding 5. Now to keep things in balance, I need to add 5 to the left. Now what happens here, I have a negative 5 and a positive 5. Those cancel to 0. So on the left side, I have x, which is equal to, I have a positive 5 and a negative 1, which is a positive 4. So I think that my answer is x is equal to 4. Now I want to go ahead and check this. So to check it, I write the original equation. Then I substitute in the 4 for x. And I ask, is 4 minus 5, is that negative 1? Well, 4 minus 5 is indeed negative 1, so it does check out that negative 1 is negative 1. So I can safely say x is equal to 4. All right, well, let's look at another example. So in this example, instead of subtracting from the variable, I'm adding to the variable. Well, the process works the same way. So since I'm adding 3 halves to z, I want to do the inverse operation. So the inverse of adding 3 halves is subtracting 3 halves. We could also think of this as adding a negative 3 halves. Okay, so if we think of everything in terms of addition, adding a positive, the opposite of adding a positive is adding a negative. Now if I add a negative 3 halves on the left, I also have to add a negative 3 halves to the right. Alright, so what does that give us? A positive 3 halves and a negative 3 halves cancel. So that goes to 0, and I'm left with z on the left. And then a negative 3 halves and a positive 1 half. So I have different signs. I have a negative and a positive. So I have more negatives. I'm going to put that on top. So 3 halves minus 1 half is equal to 2 halves. But we have the negative here. So we have a negative 2 halves. And we know simplified that that is equal to negative 1. So I think my answer is z is equal to negative 1. Let's just do a quick check. So z plus 3 halves is equal to 1 half. I'm going to plug in the negative 2 halves. Negative 2 halves plus 3 halves equals 1 half. And we're checking that. And sure enough, a negative 2 and a positive 3 is a positive 1. So I have 1 half is equal to 1 half. So it checks out that z is equal to negative 1. Alright, so I got a few on your owns to try. Go ahead and pause the video and try these. Alright, so for number 1, instead of subtracting 5 or having a negative 5, we're going to add a positive 5 to both sides. And you get p is equal to 3, which checks out. For number 2, we're adding a positive 13 and 2/10. So we need to add a negative 13 and 2/10 to both sides, or we could say subtract 13 and 2/10 from both sides. So we have different signs, so we need to find the difference, and 13 and 2/10 is the bigger absolute value. So do that subtraction, you get 2 and 8/10. So we have more negative, so that's negative 2 and 8/10, and it does check out. And last but not least, we're subtracting 5, 6 from x. So the inverse of subtracting 5, 6, or the inverse of a negative 5, 6 is positive 5, 6. So we go ahead and do negative 1, 6, and a positive 5, 6 is a positive 4, 6, which simplifies to 2/3, and again, that checks out. So in summary, our goal is to isolate x. We want 1x. That's what we're trying to find, is what's the value of 1x. So in order to do that, I do the inverse operation of the constant, that is with the x. And what I do to the left, I do to the right. And then I do my computation and get my answer. Right? Then you can always check it in via substitution. Check to see if your answer is correct. All right, that'll do it for today's lesson.